So what we're going to do is we're going to look at solving a radical equation. And what I have here is a pretty simple one. And what we could probably do is, without even any previous knowledge, we could probably solve this radical pretty simply. Now, when we're solving a radical, and I'm going to go through this a little bit slow, is when we're solving a radical, what we have to first do is solve for the radical itself. So we're going to assume that we're trying to get this whole thing right here. We're trying to get x plus 1 square rooted, and we're isolating for that. So if we look at that, we're going to just bring everything that doesn't have a square root to the other side of the equation. 5 minus 3. So we're going to have the square root of x plus 1 is equal to 2. Now, if you remember, to get rid of a radical, we just have to square it. And that's the key to solving radical equations, is to get rid of the radical, we need to square both sides. And we can do that just like when we solve any equation. If we do one thing to one side, as long as we do the same to the other, it's going to be fine. So if we square the square root of x plus 1, what happens is the squared and the radical are inverse operations. They just make each other disappear, and 2 squared is just 4. So now we just solve it like a regular equation. 4 minus 1, and we're going to get x equals 3. Now, here's the thing, though, about radical equations, is once we have done this squaring process right here, we have introduced the possibility of extraneous roots. So we always have to check. Let me say that again. You always have to check your solution to make sure that it solves the original equation. So if you don't check, you're often going to get extraneous roots. So what we have to do is we always have to go back and check. So we're going to have the square root of x plus 1 is equal to plus 3 is equal to 5. So if we put 3 in there for x, we're going to get 3 plus 1 plus 3 is equal to 5. So 3 plus 1 is 4. Plus 3 equals 5. So square root of 4 is 2 plus 3 equals 5. And so we can now say that we are quite certain that x plus 3 is the answer. So we always have to check that when we're solving radical equations. So what were those steps that I did? Well, I have them laid out for you here. Here are the steps to solving a radical equation. First, you have to isolate the radical on one side of the equation. So it doesn't matter what everything else is, you bring everything that's not a radical to one side and you isolate for the radical on the other. Square both sides of the equation, and that'll eliminate the radical. Solve the equation as you normally would, and once we've eliminated the radicals, then it just becomes either a quadratic or a cubic or whatever type of function it is. And check to see the solutions in the original equation and see if there's any extraneous roots. Again, very, very step-by-step process, and that's anytime we're solving equations, it's very, very mechanical by nature. You just do this, and do this, do this, and do this. It's always that step process. So we're going to go through this step process a little more detail in the next one, which is a little more complicated. So here is our radical equation we have to solve. So it looks pretty complicated, pretty scary, but it's really not. First step. Isolate the radical on one side of the equation. So that's what I'm going to do. I'm going to take this, and I'm just going to say that this is just step 1. If we're isolating the radical, we're going to get, well, let's go back to black here. Square root of x plus 10 is equal to x minus 2. So all I've done is I've added, or I've subtracted 2 from both sides of the equation. So that's the first step. First step's done. Second step, square both sides of the equation and eliminate the radical. So if we square both sides of the equation, we're going to get the square root of x plus 10 square that, and we're going to get x minus 2. Now, the one thing that you have to be cautious about is if you square the radical, it just gets rid of the radical, which is what we want. But if we square x minus 2, and you square that, that is not, and this is where teachers get very upset, that is not x squared plus 4. So we don't want to make that mistake, because this is completely wrong. We don't want that. If we're squaring a binomial, x minus 2 squared is the same as x minus 2 times x minus 2. So when we square that out, we're going to get x squared minus 4x plus 4. So we want to make sure we have that center term. Now if we bring everything to the same side, we're going to get, oh, I should go back and just indicate. Solve the equation as you normally would. That's all I'm doing here. This is step 3. Is we're just solving this as we normally would. It's a quadratic, so we just bring everything to the same side, and we're going to get x squared minus 5x minus 6 is equal to 0. So I just brought everything from one side to the other, and now, thankfully, we have a quadratic that is easily to factor. So this just becomes x minus 6 and x plus 1. I could have used the quadratic equation, I could have completed the square, but this is easy to factor. So that tells us that x equals 6 is a possible solution and x equals 1 is a possible solution. But we don't want to forget the last step. And this is where everyone's going to lose their marks if you forget this last step. You want to check to see that there are any extraneous roots. So we always got to go back to the original equation and check it. So I'm just going to put a line here, and we're going to say this is number 4. And to check it, all we do is we just plug it in. So let's check x equals 6. Now, I've actually down here forgot a negative. Because I got plus 6 and negative 1. So let's test x equals 6. We're going to get the square root of 6 plus 10 plus 2. Is that equal to 6? So is root 16 plus 2 equal to 6? Well, that tells you that that's 4 plus 2 equal to 6. And that is definitely a true statement. So we know that that is a solution. So let's test x equals negative 1. And we're going to get negative 1 plus 10 plus 2. Is that equal to negative 1? Is the square root of 9 plus 2 equal to negative 1? Well, is 3 plus 2 equal to negative 1? Not the last time I checked. So this is a big no. So if that's not a solution, we have to go back to our possible solutions, throw out x equals negative 1, and our only solution is x equals 6. That's how we solve a radical equation.